The last section of 7.5 is solving. So we're going to be solving trigonometric equations. So to identify that something's a trigonometric equation, first off, it won't say prove the identity. And other than that, it will contain a trigonometric expression with a variable such as cos x and an equal sign. So a classic example of a trigonometric equation is something like sine x is equal to a half. So what I want to do first is sort of show you what we're solving for and how we're solving it. Well, not how necessarily, but what we're solving for in a visual representation. And then I'm going to show you how we're going to solve it in practice. So I've shown you a graph of y equals sine x, and I've shown you how many cycles of this graph. So we usually look from 0 to 360 degrees. That's one cycle, but I've gone one cycle beyond that and one cycle behind that. So I've got 3 cycles of my sine x graph shown. I've also graphed y is equal to a half. So our solutions for where sine x equals a half is where these two graphs cross. So you'll see we've got 1, 2, 3, 4, 5, 6 solutions shown. So the question in your textbook will say something like solve sine x equals a half, and it'll either say solve between 0 and 2 pi, or between 0 and 360 degrees, or it'll say between negative infinity to infinity. So let's start off by solving between 0 and 360 because I've chosen the graph to have degrees on the x-axis because it's just easier to read than trying to make them in radians. So if I asked you, where do these two graphs cross between 0 and 360 degrees, you'd say here at 30 degrees, and then again here at 150 degrees. So they meet when x is 30 degrees. They also meet at 150 degrees. If I wanted those answers in radians, of course I just would have, been thinking in radians. So pi by 3 in radians is, 30 degrees in radians is pi by 6, right? And then 150 degrees is 30 degrees less than pi. So pi minus pi by 6. So if I'm going to subtract those, I'm going to keep a common denominator, and I'm going to say my other answer is 5 pi by 6. Okay, so these graphs cross, y equals sine x and y equals a half, cross at pi by 6, 5 pi by 6, or 30 degrees and 150 degrees. But that's in a very restricted domain. What I want to look at is, what if I don't restrict the domain? What if I said, what are all the solutions between negative infinity to infinity? So what I want you to notice is that this solution of 30 degrees is happening in the first quadrant of every single cycle of the graph. So it happens here, it happens here. If we had another cycle, it would happen there, and it also happens back here. So if I wanted to give you a general equation saying, hey, this 30 degrees is happening every cycle of sine, I'd have to determine how long a cycle is. Well, this answers at 30 degrees, and this answers at 390. How long is the cycle? How long does it take for one cycle of a sine graph to complete? Well, we know it's every 360 degrees. So I could say that I could get all of my solutions in degrees by taking that 30 and adding 360. At least that would give me the next solution. So if I wanted to add another 360, I'd get the other solution. So then I'd have to add 720 or 360 times 2. Well, what if I wanted to go backwards? Well, instead of adding 360, I'd want to subtract 360. So what if I say that I'm going to give an answer of 30 degrees and I'm going to add 360 k times, where k can be any integer. In other words, I could put in -1 and then I'm subtracting 360, or I could put in +1 and then I'm adding 360, or I could put in +2 and I'm adding 2 times 360, right? Adding 720 to get the next answer. So this is how you would get your infinite number of solutions. Now, unfortunately, there's no way of combining the solutions of 30 and 150. So you literally just say, okay, that 30 degrees is going to happen every cycle. Well, so is the 150 degrees. It's going to happen every cycle. Okay, where k is an element of an integer system. Now I checked the back of the book. Your textbook is happy if you just write these two. You don't have to write the k as an element of the integer system, but I feel like it's a really important point to know is that that's what we're putting in for k. All right, so we would do the same thing if they were in radians. We'd say that that answer of pi by 6 is going to happen every cycle. A cycle in in radians is 2 pi long. So instead of writing 2 pi k, for some reason the book writes 2k pi, but I don't really care, right? It's the commutative property of multiplication. If you write 2 pi k, if you write 2k pi, it's all the same answer to me. In fact, other textbooks I've used always use an n. I don't know why this textbook randomly uses a k, but that's okay. And then we'd have our other solution at 5 pi by 6 plus every cycle, so every 2k pi. And again, I like saying that k is an element of the integer system, but your textbook doesn't. All right, so that's how we got the solution off the graph. So how else could we get these answers? Well, we were looking for where sine x equals a half, and we have this awesome way of finding it, which is our special triangles. So if sine x equals half, opposite is 1, hypotenuse is 2, so it's our 1, 2, root 3 triangle. Across from 1 is 30 degrees or pi by 6. And then CAST, my answer would be positive in the first quadrant and the second quadrant. And so I would say 30 degrees and 180 minus 30 degrees. And so I'd get the two answers of 30 degrees and 150 degrees, or I would get the two answers pi by 6 and 5 pi by 6. All right, so we are no longer going to graph the graphs. We are going to be looking at our special triangles to be able to solve these trig equations. And let's get started. So the first one we're going to solve is where 2 cos x plus 1 is equal to 0. So the first thing you have to do when you're solving a trig equation is isolate the trigonometric expressions or the trig function. So I'm going to subtract 1 from each side. I end up with 2 cos x is equal to negative 1, and then I'm going to divide by 2, and I get cos x is equal to negative a half. Then I draw my special triangle. So I always want to put in the cast because I want to say, well, where are the solutions? Now, this wants me to find all the solutions, but in order to do that, all the questions start the same. We have to figure out which two quadrants they're going to be in. So since cos is going to be negative, it's going to be in quadrant 2 and quadrant 3. All right, negative a half. So the adjacent is negative 1. The hypotenuse is 2, which makes it my 1, 2, root 3 triangle again. All right, so what angle is across from pi by 3? Or sorry, root 3 is pi by 6. So pi by 6 would be my reference angle in radians, and in degrees it would be 30 degrees. There we go. Oh, sorry, that's wrong. Stop me. It's too late at night filming videos. So it's pi by 3 is across from root 3, which is 60 degrees. Right, so my reference angle is pi by 3 or 60 degrees. Okay, so now what we want to do is find those two solutions. So in degrees, I would say that it's 180 minus 60, which is 120 degrees, and then 180 plus 60 degrees, which is 240 degrees. Okay, so if I wanted to find all the solutions, you would say that x is equal to, actually I don't have to write it again, I'm just going to go 120 degrees plus 360 degrees k, and again plus 360 degrees k. And again, I can't stop myself, I just want to write KEI, but I know your textbook doesn't do it, so I can do it, I can leave it off. Okay, my next one I'm going to do is in degree or in radians. So the first one would be pi minus pi by 3, which is 3 pi by 3 minus pi by 3 gives me an answer at 2 pi by 3. And again, that's going to happen every cycle, so 2k pi. And then it's going to be 3 pi by 3 plus pi by 3, so at 4 pi by 3, and then every cycle. And that's it. So when you're solving these, it's very similar to, stuff that we were doing in other sections, but it will progressively get a little bit harder, but this is the general idea. So let's move on to 2 tan x plus 4 is equal to 2. So I'm going to subtract 4. So the first thing I'm going to do is isolate my trig function. So I'm going to end up with 2 tan x is equal to negative 2. And then I'm going to divide by 2. And I end up with tan x is equal to negative 1. All right, so step number 1, isolate your trig function. Step number 2, we are going to figure out our special triangle. So we draw our axes, CAST. Tan is negative in quadrant 2, and quadrant 4. Then I have to figure out which special triangle. So this is my 1, 1, root 2. So 1, 1, root 2 versus 1, 1, root 2. Regardless, my reference angle is 45 degrees, which I'll write a little bit nicer, or pi by 4. Okay, so what are my two solutions? So in quadrant 2, let's do degrees first. X would equal 180 minus 45, which is 135 degrees. Classic for forgetting to write my degree symbol. And the other solution would be 360 minus 45 degrees, which would be 315 degrees. Okay, to show that these happen every cycle, I would add 360K and 360K. But this is totally fine with me, okay? But this is not the answer that the back of the book will give. So technically this follows the pattern of what we've been doing for the past couple questions. But what's different about this? What's different about this is that this is a tan function. And tan, their cycle is not 360 degrees. It's actually 180, right? So if you think about that swoop pattern, it doesn't happen every 360, it happens every 180. So instead of doing 360, I can make it 180. So 315 plus 180. Now what I wanted to show with you here is that it doesn't really matter, because I can, like, this will give me all of the answers. This will also give me all the answers. But even a step further is that if I take that 135 and I say, well, what would the next answer be? So if I take 135 and say, okay, a cycle of tan is 180, so I'm going to add 180, I get the 315. So in fact, with tan, because of its kind of 180 cycle, you really only need to give one solution. So I would say that x equals 135 degrees plus 180 degrees K. Now again, this is only for tan, because tan has a period of pi or 180 degrees. And so if you can remember that, I definitely wouldn't do this step. I would go to here. And then if you could go even further, when you go to the back of the book to check your answers, you'd be like, oh yeah, I only have to give one of the answers, because if I add 180, I actually get the other answer. So if I was to do this in radians, okay, it would be 4 pi by 4 minus pi by 4, which gives me 3 pi by 4 in quadrant 2. And then I could just add pi k. Okay, so these are my two answers. One's in degrees, one's in radians. And again, this is only for tan, where you only have to give one. I mean, if on a test you give both, I'm not going to take marks off. I mean, yes, it's a bit of a double answer, but it's a lot to remember. Okay, so tan is the only one that's special. You can give one answer, and then it happens every pi or every 180 degrees. All right, moving on. Moving on to the next video. So go do your quick check, because we are going to add layers every single video.